Good morning, everybody. We are going to do a little bit with domain and range today. And I know that there's going to be some questions on the EOC, so here we go. Let's not forget that domain is your independent variable or your input or your X values. If you're looking at a graph, obviously it'd be the X-axis, and your range, those are your Y values or your outputs, okay? All right, so in this particular situation, if we need to find our domain and range, and again, look at the word reasonable, it's because this is a real world situation. First thing we need to do is we need to go to Desmos and we need to put in our formula for this rocket problem. So I have already done that. Okay, so teachers, you might want to pause the video and allow students to get this in. Right here is the equation that I put in. And then remember that you're going to, well, let me see if I can get this to work. Remember that you're going to need to adjust with your tool gear up here so that you can see this arc in quadrant number 1, because that is the true representation of the launching of the rocket. Down here in the negative y's and the negative x's does not matter when you're dealing with launching your rocket. So the first question says, what is the maximum height that the rocket reached? Well, if you go to the vertex here, remember height is the y. It would be 256. And then the next question says, how long did it take for the rocket to hit the ground? And we know the x-axis is the ground here. And how long is an x? So that is 8. Okay, so let's go back and fill this out. Okay, I believe the maximum height was 256. How long did it take? 8 seconds. So let's draw this. Okay. So this is where x equals 8. This is where y equals 256. Okay, so reasonable domain. Remember, this is the x, and this is time. So time from 0 to 8 makes sense. So you would say x is in between 0 and 8 seconds. This is your reasonable domain. Your reasonable range, okay, remember range of the y's, the ground is 0, and then the maximum height was 256. We need a y here, and we need your in-between statement. These are always less than signs. Small number would be ground, which is 0 height. Highest is 256 feet, I believe. Yep. So there's reasonable domain and range. Okay. So now what I want you guys to do is I want you to do this one on your own, but I want to show you something. Just bring this up. Notice we've got a little V here, and it'd probably be a V with a little O on it. And we need to find that number and fill it in. And that could happen to you in one of these problems. Notice it says V is the initial upward velocity. And if you keep reading, now keep in mind that's not the initial velocity. It says that's the initial height. But if you keep reading, it says initial upward velocity of 5 feet per second. So what you're going to do when you type this into Desmos is you're going to put a 5 here. So this is going to be 5t when you put this into Desmos. So teachers, go ahead and pause the video and let the kids see if they can figure this out. Okay, we're back. So let's go ahead and show the answers. Okay, so if we come over here, I've already put it in, and notice I've got my 5 right here next to my T. I've got my answers. So notice that maximum height, okay, is the Y. So we're just going to do 15.4 is fine. So we're going to write that down. And then time for the ball to hit the ground is over here on the x-axis. Let's just do 1.14. Okay. All right, so notice there's my maximum height. There's the time for it to hit the ground. Let's go ahead and draw a picture. And if you noticed, this one actually had an initial height of 15 feet when the ball was thrown in the air. So it kind of looks like that. And let's just, maximum height here was 15.4. And then that's your, I'm sorry, I shouldn't have put a parenthesis. This is your Y value. And then for time to hit the ground, that's my X value here, which is 1.14. So now we're ready. Remember, time would start at 0 and it goes to 1.14 seconds. So this is your domain. So my domain needs an X, and it's in between time 0 and time 1.14 seconds. So that would be your domain. Your range, remember this is your Y. And I know that this bothers y'all, but keep in mind that the ball does come down and hit the ground. So your range still starts at 0 feet and goes to 15.4 feet. And we're going to use a Y for range. Don't forget that. In between statement. 0 feet to 15.4 feet. So that's your reasonable domain and range. Okay? All right, let's go to the next problem. This is a Delta Math example, a little bit different. Okay, so notice it says, a company manufactures and sells T-shirts. The daily profit of the company that the company makes depends on how many shirts they sell. Depends on is letting you know that shirts, the number of shirts they sell is your domain. Okay. And then they say the profit in dollars when the company sells X shirts. And again, see, this X is letting you know that the number of shirts is your domain. And then they give you this function. Find and interpret the given function values, and then look what it says. Determine the appropriate domain. Okay? Now, you can probably already figure out the domain knowing that it's the number of shirts because, I mean, they could sell no shirts, which would be X is 0. They could sell 1 shirt, 2 shirts, 3 shirts, okay? But you got to go through this on Delta Math. So F of -3 means plug a -3 in for X. Notice what that means is -3 shirts were sold. Well, y'all, if you think about that, that already doesn't make sense, but we're going to go through the motions with Delta Math. Okay, so right here, we're going to do 7 parentheses, and we're going to plug in a -3, and then we've got -80. Okay, that gives me a value of -$101. So what is the meaning? The meaning is if the company sells, remember this is your X, -3 shirts. See, that doesn't make sense. They would make a profit of -$101. Okay, y'all, there is no such thing as -3 shirts. So the interpretation does not make sense. Okay. And then they're giving you more. F of 2. Well, again, this is the number of shirts. That makes more sense. So we're going to plug in this time a 2 for X. So it's going to be 7 parentheses. I'm going off this equation they gave me. 2 minus 80. Okay. -66. So that's your profit, meaning if the company sells 2 shirts, they would make a profit of negative 66. Now, I want you to think of something. Y'all, it is possible for them to sell 2 shirts. And yes, we're talking about profit. In other words, they're still in the hole. They are not making money. So this does make sense. Okay. All right. We're going to go through the motions here. 17.5. Remember, that means the number of shirts. Well, y'all, we already know that doesn't make sense because we're not going to sell a half of a shirt. 0.5. We're not going to sell a half of a shirt, but got to go through the motions. So here we go. There's my function. 7 parentheses. I'm going to plug in a 17.5 and then minus 80. Okay. 42.5, $42.50. Okay. Meaning if the company sells 17.5 shirts, I got that from my X value, they would make $42.50. Okay. This interpretation does not make sense. The reason why it does not make sense is because we cannot sell a half a shirt here. Okay. So now, based on the observations above, it is clear that the appropriate domain is. This is where we've got to go back in time a few years and remember what all these things are. Okay. Real numbers. Remember, those include decimals, such as 0.5. Well, like we said, we don't have half of a shirt, so we're not going to use real numbers. Okay, and again, this is just real numbers between 2 values. We're not using that. Non-negative real numbers. Again, we're not going to do any decimals. Integers, keep in mind, integers are negative numbers, like -2. It can also be 0. It can also be positive numbers, but we're not going to sell a negative number of shirts. So integers doesn't make sense. Again, integers between 2 numbers doesn't make sense. So we're down to these 2. So whole numbers, remember, include a 0. Positive integers start at 1. Those are like your counting numbers. Well, keep in mind, can we sell 0 shirts? Sure we can. So whole numbers is the appropriate domain for this function. Okay? Okay. So let's go to the next one. Okay, the next one is talking about temperature. If the low temperature outside is X degrees, so they're telling you that X stands for temperature. The domain stands for the temperature. The daily cost to heat the building can be determined by this. So y is the cost? And they're giving you a function. Find and interpret the given values. And then notice again here, we're talking about finding the appropriate domain. Okay. So we're going to go through the motions here. Keep in mind, the X is temperature. Okay. So we've got -7 for the temperature. Okay. So we're going to pop that in our function. And again, keep in mind, that's an exponential there. So we've got 10 parentheses, 1.3, and then we need a caret key. And I would just go ahead and use a parenthesis here. Negative X. Now be careful. This is negative and this is negative, which makes a positive. Keep that in mind. Negative times negative is a positive. Okay, we're going to press enter. Okay, let's see. Round all functions to the nearest hundredth. So the nearest hundredth here is going to be 0.75. So 62.75. Okay, meaning when the low temperature outside is -7 degrees, it would cost $62.75 to heat the building. This interpretation does make sense. Okay. Why does it make sense? Y'all, temperatures can be in the negatives. That's okay. All right. Now, we're going to evaluate f of 3. Remember, 3 is the temperature, so it would be 3 degrees Celsius. So we're going to pop this in again. Now, keep in mind, there's a negative on that, so it's going to be -3 that's going to go in here. Okay, and we get, round to hundreds, $4.55. Okay, meaning when the low temperature outside is 3 degrees, it would cost $4.55 to heat the building. Well, again, temperature can be at 3 degrees. So this interpretation makes sense. Okay. 3.5, again, that would be your temperature. Well, we know that temperatures outside don't have to be whole numbers. We can have 3.5 degrees Celsius. So we already know that makes sense, but let's plug it in to get our numbers. 10 parentheses 1.3 caret key. Remember, there's a negative on the x, so that's going to be -3.5. And we get 3.99. Okay, so when the temperature outside is 3.5 degrees, it would cost $3.99 to heat the building. The interpretation makes sense. Okay, so now this is where we're choosing our appropriate domain, the x values. So for temperature, negative temperatures are possible, positive temperatures are possible, and notice a decimal. In other words, not just whole numbers, but all the little decimals in between also make sense. So remember, real numbers have to do with decimals. They have decimals in them as well. So the appropriate domain here is all real numbers. Okay. All right. And one last little domain and range problem that looks different than the others. Okay, notice this says find the range. So we are finding the y values for the following equation. And here's the weird thing. They are actually giving you the domain values. In other words, the domain is being restricted to just these 4 values. Remember, domain is the x, so they're giving you the x values. So what you have to do is evaluate the function at these x values to get your y values. So this is what it would look like. We are going to do f of -4, f of 0. In other words, we're going to plug these in. F of 3 and f of 9. These are the 4 domain values they give me. So what does this sound like? 2 blank minus 7. Okay, here we're going to plug in -4 for my x, 0 for my x, 3 for my x, and 9 for my x. Let's see, that's going to be multiplied there. It's going to be -8. I think that's going to be -15. That's going to be a 0 minus 7 is going to be -7. This is 6 minus 7 is a -1. 9 times 2 is 18. 18 minus 7 is 11. Hope I did that right. I'm sure if I didn't, somebody's going to let me know. So keep in mind, these are your inputs or your x's, and remember that what we get out are the outputs or the y's. Well, it's asking for the range. Those are the y values. So this range is 4 particular values. It is -15, -7, -1, and 11. So this would be your answer to find the range. We input 4 values for the domain, and we get 4 values out for the range. Okay? All right, so teachers, why don't you let the folks try this and pause the video. Okay, Given domain, we're going to do f of -2, f of 1, f of 7, and f of 12. Okay, what does it sound like? 4 blank minus 1. Okay, we're going to pop in a -2, a 1, a 7, and a 12. We're going to do the math here. -8 minus 1 would be -9. It's going to be 4. 4 minus 1 is 3. 28 minus 1 is 27. 48 minus 1 is 47. These were your domain or x values. Remember, what you get out is your range or y value. So it says find the range. So the appropriate answer is a list of 4 numbers: -9, 3, 27, and 47. All right, you guys have a good day.